going to look at today is section 8.4, and it's parametric equations. Now, hopefully, if you've been doing the homework, the polar went pretty smoothly, especially the graphing ones. Parametric equations really going to have three main types of questions. Kind of focus issues. Come on, there. Right. First one is going to be graphing parametric equations. Very like the polar. They'll give you a parametric equation and you'll have four pictures, or yeah, typically four pictures to pick from. You pick A, B, C, or D. So we'll look at that. Second one is second kind of question is you're going to find a particular coordinate for a given value of t. So they're going to give you a parametric equation. X equals t cubed, y equals t plus 1. Where is the object at time 0? Well, that just means make t equals 0 and tell me the x and y coordinate. Okay. Is this not coming through well, Courtney? Is it kind of blurred or kind of you? Is it the same for it? Is that better? Right, as long as I keep my hand here, it focuses well. I'm not quite sure that's feasible, but I'll try. And the third thing is eliminating the t, which is essentially going to be take the parametric equation and convert it into a formula that uses x's and y's. So let me make up a question like that. Suppose you were told that x equals t squared plus 1 and that y was t cubed, take away 5, right? Just for example. Now, the first question would be graph this guy. So let me show you how I would do that. I'll have to share. I can make the share happen. Here we go. And where are we? Is it here? No. Is it here? No. Here it is. Okay. Can you see the parametric equation graph, or we'll have to go out and in again? You can't see it. Okay, I'll go out and in again then. Out and in. Right, you should see it now. You see it now? It's called the parametric equation graph, right? If you go to your Canvas site, your Canvas shell, it's in the front page. It's called parametric equation graph. Right, so in this case, it's x is t squared plus 1. That's very good. Y is going to be t cubed minus 5. Oh, and let's suppose that they tell you t goes from 0 to 3. Right, so you type in x formula, you type in the y formula, you type in where you start, where you finish, right, from 0 to 3. And then we should be able to see it happen. There it is. Can you see it's a pretty boring curve? Because I wasn't that, I guess I wasn't that good at picking one, right? But can you imagine you get 4 pictures and one of those pictures looks like that guy? And that's the one you pick. So just like in the polar. Since I'm up here, maybe I could make it do something a little bit cleverer. I don't know if that'll make it any better or any worse. Nope, it's still a pretty boring curve. Okay, I'll give that up as it goes, right? So you plug it in, you look at the picture, and hopefully you get to see whatever it is, whatever the shape happens to be. So that's kind of phase one. Yeah, you draw it in, you compare it to some pictures. Now, the particular finding, let's suppose you were asked to find where the object was when t equals 0. Well, the x coordinate is 0 squared plus 1, so that's 1. The y coordinate is 0 cubed, take away 5, so that is -5. And so they would be looking for the point with coordinates 1, -5. Does that seem reasonable? Time is 0, plug in 0, you get what you get. Now, they may phrase it differently. They might say, where was the object when it started? Well, that's another way of saying where was it when t equals 0? And they might say, what's it like in the 3-second mark? Well, x will be 3 squared plus 1, which is 10, and y will be 3 cubed, take away 5, which I believe is 22. So your answer in this case would be that. So as long as you tell me what the t is, can't I plug it in here and get the x coordinate, plug the value of t into here to get the y coordinate, and that will be the coordinates of the point they're asking for. Right. So nothing too weird, right? Pretty obvious what you have to do. Right. So the hardest part is obviously eliminating the t, right? So let's start with our equation. Now, the key to doing most of these is substitution. So how does that work? Pick an x or a y that you can rewrite as t equals. Okay, now in the question, that's going all bloody again. Here we go. In this question here, if I look at x, could I eventually get t equals out of that? Yeah, would be particularly pretty. If I go to y, could I make that t equals? Yeah, wouldn't be particularly pretty either. So I'm going to go with the x. So x equals t squared plus 1. If you subtract 1 from both sides, you get that. And if you take the square roots of both sides, you'll get that. Now, normally, when you take the square roots of both sides, you should say plus or minus here. But can we make the assumption that t is a positive thing because it's time? And we're not doing time travel where we go backwards, right? So I'm using the positive value. So once you've got that, the next part of it, call that A. Part B is use this fella and substitute it into the other equation. So in this case, the other equation is that guy, right? Which means y is going to be the square root of x minus 1 cubed, take away 5. Are we comfortable with this process that I've used in this question? You pick one of them to get a t equals, and then you plug into the other one. Now, in some situations, and I don't think this is one of them, But in some situations, you know, you can make it look a little bit prettier, foil things out, collect like terms, do what you need to do. I think in this case, you're really not going to be able to do much. So you might as well just, you know, call it good. It's finished. I'm seeing some nods I like. Okay, so I'm going to try now.
Could I?
And
Yeah,
yes.
for 1 minute, I think I missed something.
Go.
Good to go. Thank you.
Okay. So let's nip back and look at some of the questions that we have, and we'll see if we can make them up here. Right. So who shall I pick? Let's pick number 3 because it's very easy. When you're doing a parametric equation, do you know that the piece of the curve, because very often it starts at this value and it finishes at that value, the piece of the curve, you travel along the thing in a certain direction. So t equals 0, you're here, t equals 1, you're here, t equals 2, you're here, t equals 3, you're here, so you travel this way. That's going to be important. So I'm writing down x equals 5t and y equals t plus 3. That's not a very unusual or difficult parametric curve. So let's go into here, not here. Where is it? Oh, here. And try that out. So this guy here is going to be 5t. And the second fella was going to be called t add 3. Okay. Now, should be good, right? Now, you see this little slider here? I'm going to kick this off in a minute. You see this little slider? Slide me to draw a curve. If I take this, do you see it? T equals 0, you're at 0, 3. You see that little dot? Now, as I move this thing, can you see, I'll start again. Can you see the direction that that thing is moving? Right? You start here, then you get to here, then you get to here, and so on. So if I do a little baby picture of what that is, because I have to leave it in a few seconds. This is what it's going to look like. Right? Not very detailed, but that should be enough for me to figure out which of the 4 pictures they were talking about. Right. So zooming back into our next fella. Here. When you look at the 4 pictures, and that's only the bit of the picture I drew. Yeah, can you imagine the rest of it going like that? When you see this one here, which one of them actually is the only one that fits the picture I drew? Would you agree it's D? You see it starting at 3 and it's going that way. This one's no good. This one's no good. This one starts at 3. Do you see it's pointing the wrong way? Actually, it's sloping the wrong way as well. So that's a double whammy for it. So that's how you got, or that's how you would use this little feature, right? And if it has, what I was hoping to see, and I'm sure they're going to get that, is, do you know that you're going to get 2 pictures? And that's the only difference. Now, in that case, it's much more important that you noticed which way the line was being drawn. In the other one, you got away with it because there was really only 1 picture. But when they start getting a little bit trickier, you're going to have to figure that out. Now, let's eliminate the T. Now I'm going to take x equals, and that's going to get me 1/5 x. I'm going to plug that into t add 3, and that's going to get me 1/5 x add 3, and we have now eliminated the t. That was very easy, right, algebraically. Are we good? Is there any questions so far? Okay, so I'm going to pick some of my own, and I'm going to skip the draw me thing. I think the draw me is pretty straightforward, right? And I'm just going to focus now on number 2 and 3. 2, find the coordinates at a particular t value and eliminate the t. There we go. Right, so here's my made-up question. And let's suppose that you're being told to find the coordinates when t equals 2. Well, the x coordinate is 2 squared plus 1. That's 5. The y coordinate is, oops, 2 lots of 2 squared, take away 4, which is 4. So the coordinates that you're looking for is 5, 4. Are we comfortable with that type of question? Okay, now the eliminate. Technically, I could use either one of these two, right? They're both equally ugly. Well, this one's maybe less ugly, but not by much, right? Both doable, right? Both could be rewritten as t equals. When you have a choice of both of them, well, you always pick the x one, because it's going to make your formula y equals much, y equals a function of x, which is typically the way we like functions to be written. Now, in this case, subtract 1 from both sides. And in this case, take the square root. And again, I'm using the argument that t is positive, so it's a positive square root. And then go over here and do 2 lots of this guy squared, take away 4. Now, in this case, you might just think, I'm just going to leave it. That's what we did with the last one. But I don't think you should in this case, because you can do better. Right? We can make this look nicer. In particular, isn't the square root of x minus 1 squared quite a nice thing? What does x minus 1, the square root of x minus 1, all being squared, get you?
X minus 1.
As simple as that. And there's something that you probably weren't expecting. That this particular parametric equation, even although it's got squares in it, doesn't generate some kind of quadratic, so you might expect a quadratic here. It actually just generates a straight line. So you have to trust the math here, because otherwise you might, talk yourself out of that answer. Are we good? How about this next one? Now, I've chosen this one. It's slightly different, but only slightly. Now, I could do it the usual way, which would be to find one of these equations and write it as t equals, right? And I'm going to do it that way. And then I'm going to show you a nice little shortcut for this particular situation. Now, I'm going to focus on the x again. So x take away 1 is e to the t. And now it's going to get a little bit tricky for you, because it's a while. what would I need to do to both sides to convert the e to the t just into t?
Take the natural log.
Right. So it's already getting pretty ugly, isn't it? It's that guy. Now you plug it in here, you get e to the power of 2 natural log of x minus 1s, take away 3. And the homework is very unforgiving. If you type this into it will say wrong. It's not wrong, it's just only 50% right. Okay. It can be made prettier, but in order for you to do that, you have to remember some log properties that you haven't used in a while. For instance, isn't 2 times the log of something the same as the log of the something squared? So this becomes e to the natural log of x minus 1 squared, take away 3, which is better, but not much better. Now we're going to use another property of logs. Isn't, whoa, come on, focus back. There we go. Isn't e to the natural log inverses of each other? So e to the natural log of x minus 1 squared will get you x minus 1 squared. Now, this is much better than it was a while ago. Can it become even better? Is there anything else that you should be able to do just to make it look a little bit prettier?
Foil.
Right. So you get x squared, take away 2x plus 1. And that gets you x squared, take away 2x, take away 2. There's a quadratic. So we did follow the rule of choose one of the 2 equations to get to the form t equals and then substitute. And I promised you a shortcut. So here goes. Right, that line just like we did. Now, if e to the t is this, won't this fella be e to the t squared? Which makes it x minus 1 squared, which means that we jumped straight to that line. And we know what that answer is, so I'm not going through all the steps to it. Now, do you see what that did is that it cut out a whole load of taking logs to both sides, and 2 times a log of something is log squared, and a log of an e cancels out. It took away all that math, and it basically just said, look, if I know what he is, then he's this guy squared. So that's the only kind of property that I needed to worry about. Any questions about that one? Are we good? Right, let's look at this fella. I'm going to do a question where x equals isn't the way to go. We have to do the y equals version first. So let's suppose we had t squared plus 2t plus 7, and y was t minus 3. Now, if I was looking at picking one of the equations to rewrite as t equals, would you agree that that one is not going to work very well? But won't this one work really well? So if I add 3 to both sides, t is y plus 3. Now, all I do is I substitute it into here. So x equals, instead of t squared, y plus 3 squared. Instead of 2t, 2y plus 3s, add a 7. Now, you might be saying, oh, wait a minute, that's not the way equations should be written. You are allowed to do any version that makes the t disappear. These are called implicit equations. That's just means that's what they are. I'll give you an example. Isn't x squared plus y squared equals 1 a circle? We don't write that as y equals because it really doesn't look very nice and it's quite hard to deal with. So some functions won't look y equals a function of x. Some functions will look more like x equals a function of y, or a formula of y. In this case, I would FOIL everything out, distribute, and then collect like terms. And that is the correct answer. And just to make life awkward, isn't that also the correct answer? Take y squared away from both sides, take 8y away from both sides, and this is what you get. And just to make life really, really awkward.
I think you forgot to add the 6.
Oh, I did, didn't I? Okay, fix it. 22, 22, Wilcott, 22. Hopefully that adds up right. Right. Now, third version, second version, first version. You know how quirky the software is? You might want to do a couple of examples to figure out which of these three it's comfortable with. I'll tell you what it will be comfortable with. See the ones that look like that? I'm pretty sure that's the only way you would write it. But see the ones where the X's and Y's are kind of, back to front? They may be okay with that. If they are, don't worry about it. Write that answer down. The first one you do, if it says yes, go for it. If it says no, well, you try version 2. And if it still says no, well, you try version 3. And by that time, hopefully, I'm assuming you didn't do a mistake like I did, right? You'll then get to, it might be versatile. I hope it is. I hope that any one of the three will be acceptable and, don't you worry about it. That's what I would hope. But, you don't always get what you want. We feel comfortable about that one. Right. So what I'm now going to do is jump back into, share screen. And here we are in our questions, and I think I should move closer to the end where we might get some cool ones. That's a good one, but I don't want to do that one first. Yeah, it's right. I won't do this question, I'll just talk it through. If you were going to do question 8, the one that hopefully you're all looking at, would you agree that you could take the x and rearrange it to get a t equals? I think it's simple enough for me to do it in my head. Wouldn't you divide both sides by 4 and then take the square root? Now, if you do that, doesn't t equal the square root of x over 4? And then you plug it into the other guy and you get the answer. Now, there is something interesting. They've given the answer as y squared equals x cubed. It's very interesting. So I am going to do that question now that I've seen what they wanted. So we're just going to eliminate the parameter. And if you divide both sides by 4, you get that. And if you take the square root of both sides, you get that. That's what I said. And then you go over here and you get 8 times the square root of x over 4 cubed. And I better put my square root like that. It's the square root of the whole thing. Okay, so That's 8 times the square root of x cubed all over the square root of 4 cubed. That's 8 times the square root of x cubed over square root of 4 is 2 cubed. Oh, 2 cubed is 8, so they cancel out. So now you are looking at that guy. Now, that's not the answer they got, but that is correct. Agreed? So that's the same thing as the square root of x cubed. Right, you can bring the cube inside. Now, you might say, where did they get their answer? They squared both sides. So that's how they got the weird answer that they got. Now, as far as I am concerned, that is the correct answer. And that is also the correct answer. I'm hoping that if you type this in, it says okay, and you don't need to worry about it. I'm hoping that if you type this in, it will say correct. If not, you're just going to have to figure out what the heck it's written as. Now, in a test, if you're doing the test 4, and you write that down, and the book or the software says you're wrong, you will get full points because that is correct. It's just they're not clever enough to realize there can be more than one correct version of in some circumstances, right? And that to me is just as nice and as pretty as that guy. I mean, they both have advantages and they both have disadvantages. The reason I like this one, it's y equals, right? We always like y equals if we can do it. And the reason why I like this one is there isn't any funny, awkward square roots floating around. What about the third guy? Isn't he the same as the other two? Equivalent, at least? So if you were doing a test in any one of these three, I'm totally happy, right? They're all correct. They're correct, different flavors of the correct answer. Are we good?
I just wanted to add one thing. I tried that y equals the square root of x cubed, and it didn't like that one.
It liked this one?
Yeah, like the middle one.
Darn it, I was going to ask you to try this one, but your question's probably gone now, right?
Yeah, I have one more submission.
I don't want to lose your point in case it doesn't accept that one. It looks like it likes this one, it hates this one, and it might or might not like this one. Okay, you're just going to have to be in the lookout when you're doing your homework. You know, if that flavor doesn't work, it wants the next flavor, right? You know, if that flavor's not working, it's this one, and Rocky Road's my last chance, right? And hopefully that'll sort itself out. That's not wrong. The software is wrong in not accepting that as an answer, right? So it's not that you've done anything wrong if you've got this. It's just, unfortunately, if you want to get your homework. If you come across a homework question where you've run out of shots, if you shoot me your answer that it said was wrong and it is actually a flavor, one of the correct versions, I will just give you the point, right? I'll go back in and change it for you, right? So if you really end up, you know, on your last attempt, it not accepting it, but it was really correct, we can fix that. I think that's the way we'll go around that. We good? Right. Now the next fella I'm going to do is one with trig in it. Because we have to change the rules a lot here. The substitution trick doesn't really work, at least make one of them, either this one or this one t equals, doesn't really work. You can theoretically do it, but the answer you get is so ugly, it's not acceptable. And there is a much prettier answer. So let's show you I'm going to do this. I start off by trying to get the simplest version of t that I can on the right-hand side. In this case, sine t. In the other case, cosine t. You happy about what I did? Divide both sides by 2 and then divide both sides by 3. Now, the leap. I'm going to do something that allows me to combine these two pieces of information. Have you any idea what I'm going to do to both sides of x over 2 equals sine t? And I'm not talking about inverse sine, because that's the wrong road to go. I know it makes sense, but it's not the way to go. Last chance before we tell you, what should I do to both sides to kind of turn this into something that later on is going to be useful? I'm going to square both sides. Are you okay with me just doing the square in my head from writing it down, then writing x squared over 4? X over 2 times itself gets you that. Now, in the same way, I'm going to square both sides here. Oops, don't need 2 equals here. Right, you see we've got x squared over 2 is the same thing as sine squared, and y squared over 9 is the same thing as cos squared. And I'm just going to rewrite them one above the other. Any ideas what we can do in the next line? Last chance. How about adding? Adding the two things on the left and adding the two things on the right. You're doing it to both sides. So x squared over 4 plus y squared over 9 is sine squared t plus cos squared t. You always got to keep in your mind what you're trying to do here. Aren't you trying to eliminate the t's? In other words, make them go away. What does sine squared t plus cos squared t turn into? You got it. We're finished. You see? A little bit different. Now, how do I know that I'm going to do that? If you ever see a parametric equation with sines and cosines, right? Doesn't matter if that's cosines or sines, doesn't matter if that's cosines or sines, as long as you see one of each, then you're going to do a technique very similar to this. A slightly more awkward version is secants and tans. So if you ever get one with a secant and a tan, you can do a very similar kind of calculation. The only major difference is that you're going to do tan squared to take away secant squared and get 1. So it'll be the top guy take away the bottom guy kind of thing. Just out of curiosity, does anybody know what that shape looks like? It's an ellipse. Now you have to make sure, when you're setting up, it's quite hard on your calculator because it's not really designed for sketching functions that look like that. But it is an ellipse nonetheless. If you use the parametric grapher that I've given you, it only does, I think, 0 to 5. So you're probably only going to see this side of the ellipse, or not all of it, maybe the top part or something like that. But the rest of it, if you did more t's, would give you the whole picture. So let's go back in one last time. Now, if you do 4 sine t and 4 cosine t, you end up with x squared plus y squared is equal to 16. Okay. Now, imagine I did this, fella. I'm going to show you. Actually, this is our last one for today. Let's suppose we'd 4 sine t, and y is 4 cosine t. But t only goes from 0 to pi, right? Okay, so x over 4 is sine t, y over 4 is cosine t, x squared over 16 is sine squared t, y squared over 16 is cos squared t. When you add them, you get x squared over 16 plus y squared over 16 equals 1. Now, if you multiply both sides by 16, you get that slightly prettier version. Oh, it's a circle. Well, it would be if you went all the way around, agreed? But you're only doing that much. So, when t equals 0, the x coordinate is nothing, and the y coordinate is 1. When t equals pi, the x coordinate is still 0, and the y coordinate is -1. So 0, 0 in the x, 1 in the y, -1. Start, finish. That's a piece of the circle you get. So if you wanted a whole circle, you'd start there and you'd finish there, right? You get the whole circle. So if you're wondering why some of the pictures aren't a complete shape, it's because you're not allowing the T to go all the way around the shape. So you might only get half an ellipse or half a circle. It might be the top half, it might be the right-hand half. It depends on the T values, and it depends on, what's going on here. And that's a perfect time for us to finish. Is there any questions for relief?
Yes, I had
Yes, what is it?
question 10. Instead
Okay.
of having both sine and cosine, it just has sine t and cosine t and cosine 2t.
Okay, so let's do that one right now. So x is equal to
Cosine t,
and y is equal to
cosine 2t.
Interesting. I'm not going to do anything to that guy. Do you know that cos 2t can be written in 3 different ways, called the double angle formulas? So if you've got that formula sheet handy, you bring it out and look at it. One of them says cos squared t take away sine squared t. No good. One of them says 1 minus 2 sine squared t. Not good. And one of them says 2 cos squared t take away 1. But if cosine t is x, if cosine of t is x, then cosine squared is x squared, then 2 cosine squared is 2x squared. And that's pretty much it done. Now, I don't know if they go 0 to 2 pi or anything, so I know what that looks like roughly, right? It looks like that guy, right? But you might only get this piece because they go 0 to 2, or, you might only get this piece. You might get the whole thing. It depends on, do they have a T thing going on here? Is there a restriction on the
Yes.
T?
Yes,
So
there is.
it's from where to where? What's the limits? I'm doing 0, just assuming it is. It might not be 0. Do you have that handy?
Actually, that's part of the question. They ask you what that is. And
Oh.
they don't give it.
You could do 0 to 2 pi, right? Or you could basically do all real numbers. So I'm not quite sure unless I look at the specifics of it. If they do all real numbers, then I guess you're talking about that. So unless there's some other information I'm not privy to. Does the question say what was the range of t's? Does it say it like that?
No.
At least on mine, it's asking about X instead of T.
Oh, okay. Right. Does it specifically give you a t value to start the range off? Because that I can use.
It
Do you
just says,
see?
it says where blank is less than or equal to X, and X
Hold
is
that
greater
thought
than.
then. I'm just going to go
or-
in and we'll all see what these question looks like, because they do tweak them a little bit. Right, so they say sketch the curve. So I'm assuming that my 2x squared minus 1, it's this picture, which it is. And then it says, oh, okay. Yeah, it's not a very clear question. I know what the answer is. I can see it in front of me. Let me explain why it is. Do you know how we picked this picture here? Right, that's the one that worked, right? That's the x squared minus fella, right? Do you notice that it starts at -1 and it finishes at 1? And that's where they're getting these two numbers from. I don't think that's a fair question, because really, they just decided to draw it from -1 to 1. Couldn't they have drawn it? Well, let me rephrase that. I now know what they're getting at. Since x is the cosine of t, what's the biggest value for the cosine of t?
1,
Right, and what's the smallest?
-1.
There, that makes more sense in my brain now. That's why it's -1 to 1. Right, x can only be whatever cosine t is equal to, and cosine t can only be numbers from -1 to 1, so that makes x can only be numbers from -1 to 1. Does that make sense now? So that question wasn't as vague as I thought it was. It did have a sense to it. Are we good? Right, well, I have another class. Nice to see you. Hopefully you get through this section and you'll be ready for next week's work. You'll have a quiet weekend for a change. That would be nice. Okay, bye-bye, everybody.
Have a good weekend, Professor.
You too. Bye-bye, Morgan.